Hello, I am Sebastian again. I will make a quick presentation of one of the projects in which I work in is the graph algorithms. Actually, this is by default in the Faro image, so you don't need to install anything. For example, let's open Calypso, and can you see the letters? Yeah. Well, it's alphabetical order, so you can see, for example, that is like literally the first package on the browser. So basically, we implemented, well, there are some of the algorithms that were already implemented in Moose, and we migrated them, and we fixed some of them, and actually I added some of them. And well, and the API is pretty straightforward. For example, let's say that I want to make a topological sort of a graph. And for that, I have a list of nodes, and this list can be any type of object. In this case, for simplicity, I chose to put characters. Then I need to declare the edges of the nodes. In this case, for example, the node A goes to B, A goes to C, B goes to E, and etc. And then, as you can see here, all the algorithms are a subclass of AI algorithms, so they all have the same API, and this API is pretty simple. So we declare the algorithm. For example, in this case, it's a topological sorting algorithm. We say, okay, these are the nodes. These are the edges that goes from the first to the second, because as you can see here, the edges are declared as a list. But again, the edges can be any type of object. You only need to specify here in the front two which message do you need to send to get the relationship. And for example, if we execute this, and then we run the algorithm with the method run, and okay, we have this is going to return us the topological sorted elements. We can inspect this, and okay, we are going to have a list of the topological sorted elements of this graph. We can also apply, for example, we have the BFS, Bellman-Ford, Dijkstra, Graph the Dozer, and etc. Also, I will show here, I don't know if it is, okay, but here in the wiki, if you go to the Faro AI Faro wiki, you have here a place that says state space search, and if we go on until the end, we have graph algorithms, and then if we click, we have a little explanation, but we also, with Steph, we wrote a nice book on this. So if you are interested, you can, what is happening? So you click here, you have directly the PDF from here. And okay, if you are interested in reading about graphs and of that super funny stuff that is math, you can hear here, and there is more examples here. And also one last thing is that actually this is installed by default in the Faro image, because this is used in the dependency analyzer, because in the process of migrating this, we find out that actually the dependency analyzer was using a broken version of the Tarjan algorithm. So it was not actually doing that. Maybe there were some errors or not. And the Tarjan algorithm, here we can see the dependency analyzer. It has here run Tarjan that has the Tarjan algorithm, and this is basically an algorithm for finding the strongly connected components of a graph. That is like the components that are related, they have like a circular dependency, kind of like that. So well, this is using in Faro by default, and now we wrote more tests to make sure that now the Tarjan algorithm is actually working properly. So that's it. Thank you.